Hi, I'm glad we are back to work on a new section of our course. And today I don't bring a puzzle, it's more of a challenge. And the challenge is, can you describe the graph of the equation in one word? This is the equation, and you need to find out a way of graphing it. You can use a graphing calculator, you can try to graph in graph paper, is up to you. But can you describe the graph of this equation in one word? This is the challenge today. We will check this at the end of our lesson. Okay? And we will work on chapter 7, rational exponents, radicals and complex numbers. Section 7.1, radicals and radical functions. The first objective is to find square roots, and opposite of squaring a number is taking the square root of the number. So if you have a equals b squared, right? So you're going to have square root of a equals to b. That's how you find out how you can define the square root of a number. And the principal square root of a non-negative number, a, is its non-negative square root. The principal square root is written as square root of a, and the negative square root of a is going to be written as negative square root of a. This is because if you're going to solve a few problems that involves the square root or the square of a number, you will have sometimes two answers. One is the positive or the principal square root, and another one is the negative square root of the number. We will see this later on a few examples. Find each square root, and now is the principal, the square root of the number, the positive square root or non-negative square root. Square root of 79, the 49, 49 is 7 times 7, right? That means square root of 49 is 7. The square root of 25 over 16, we can calculate it by finding the square root of 25 over the square root of 16. 25 is 5 times 5, 5 squared. That means the square root of 25 is 5. And 16 is 4 times 4, 4 squared. That means square root of 16 equals 4. Negative square root of 4. So calculate here square root of 4. The non-negative square root of 4 is 2. 2 squared is 4, right? So the answer is 2, but you have a negative sign in front of it. So keep the negative, negative 2 is the answer. Square root of 0.81. You can write 0.81 as the square root of 81 over 100, right? And this is square root of 81 over square root of 100. 81 is 9 times 9, 9 squared. That means the square root of 81 is 9. And 100 is 10 times 10, 10 squared. That means square root of 100 is 10. This is the answer. You can write as a decimal 0.9. Now check letter E. Square root of 9 times x exponent 10. You can split, you can write this as square root of 9 times square root of x exponent 10, and the answer is going to be square root of 9 is 3, because 9 is 3 times 3, right? 3 squared, and square root of x exponent 10 is x exponent 5. And the next question, letter F, is negative square root of 25. Again, the same thing we've done on letter C. We have this negative sign in front. The non-negative square root of 25 is 5, because 5 times 5 is 25. And then we have this negative sign in front of it. You just keep, the answer here is negative 5. Now, letter G. This is a different situation. Let me erase here so you can look well at this, very well. And pay attention, because the negative is inside the square root. Now we have a completely different situation. And we cannot find any number, any real number that multiplied by itself makes negative 25. Like 5 times 5 is 25. Negative 5 times negative 5 is positive 25. So we will not have a square root of a negative number. So we have no solution here. No solution as a real number. Not a real number. Okay? Alright, moving on, because now we will work on objective number 2, approximating roots. This is quite simple, and we will see this real quickly. Let's say we have a square root of 5. If you type in your calculator, you're going to find a bunch of numbers, right? The square root of 5 equals 2.236067977, and then depending on the calculator, you're going to have more and more numbers here. Okay? To approximate, you just will, the question will ask you, it will say how many decimal places you need. So we will approximate the square root of 5 to 3 decimal places. That's what the question is asking. 2.23, and since the next number here is a 0 after 6, right? Is a 0. If this is less than 5, we will write here 6. If this number here after the last decimal that we will represent is more than 5, then we will write it as a 6 plus 1, 7. In this case, just 6, 2.236. This is the answer. Okay. And next example, next objective, find the cube roots. So cube roots, and the cube root of a real number is cube root of a equals b if b cubed equals a. A is not restricted. This is an interesting thing, because if we're talking about a square root, we cannot have a square root of a negative number. We have seen the last example. But for cube root, it's not a problem for cube root. We can have a cube root of negative numbers. Check the examples. We have cube root of 27. 27 is 3 times 3 times 3. 3 cubed, right? So cube root of 3 cubed, that means is 3. The answer is 3. Cube root of negative 125. And I told you, for square root, we cannot have a square root of a negative number. It's not a real number, but for cube root, this is not a problem. Let's say, because negative 125 is negative 5 cubed. Okay? And the cube root of negative 5 cubed is negative 5. Not a problem. Cube root of 8 over 125. We can write as cube root of 8 over cube root of 125. And 8 is 2 cubed, and 125 is 5 cubed. So cube root is 5. And the last example we have here is cube root of negative 8 times x exponent 9. We can write this as cube root of negative 8 times cube root of x 9, and then cube root of negative 8 is negative 2, cube root of x exponent 9 is x exponent 9 divided by 3, 3. That is the answer. Okay, next we have objective number 4. Find nth roots. So we just worked with square roots, the exponent 2, with the index 2, I mean, cube roots with the index 3. Now we will find roots with index n. Other roots can be found as well. The nth root of a is going to be defined as nth root of a equals b only if b exponent n equals a. If the index n is even, the root is not a real number when it's a negative. That means we cannot have we cannot calculate the nth root of a negative number as long as the index n is even. That's the same thing we have seen to square root, remember? And if the index is odd, that's not a problem. We can find the nth root of a negative number as long as the index is an odd number. The same thing we have seen for the cube root. Let's work on those examples. Find each root. Letter A, the 6th root of 64. And we can think 64 is equals, let's write here, 6th root of 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64. This is 1, 2, 3, 4, 5, 6. Right? So 6th root of 2 exponent 6. The answer is going to be 2. Now the 5th root of negative 32. We can have the same thinking. 5th root. And just get rid of this. 5th root. Negative 2 times negative 2 is 4 times negative 2, negative 8 times negative 2, 16 times negative 2, negative 32. This is 1, 2, 3, 4, 5. That means 5th root of negative 2 exponent 5. The answer is negative 2. Right? This is the answer. Now we have a situation and 4th root of negative 16. And this is going to be a problem. Think about it. Let's move this to the bottom, negative 16. Let's think a little bit about it. Because negative 16, if I multiply negative 2 by negative 2, I have positive 4. By negative 2, I have negative 8. By negative 2 is positive 16. I cannot have a positive number and the 4th root of negative 16, because this index is an even number and I cannot have the nth root if the index is an even number, of a negative number. So this is not a real number. Okay? We will not have a solution as a real number. All right, moving on. Next objective, number 5. Find the nth root of a exponent n when a is a real number. If n is an even positive integer, then nth root of a exponent n is equals to absolute value of a. This is kind of a general rule to find the nth rule. If n is an odd positive integer, then nth root of a exponent n equals to a. Let's check some examples to understand how to work using this rule. Letter A is a square root, right? So if it's a square root, you're going to apply the first rule. Is if you have this situation, it's going to be absolute value of a. Square root of -4 squared is going to be absolute value of -4 equals 4. Okay, that means every time we have any negative number squared, it will become a positive, right? Negative with negative, positive. So that's the reason we can apply this rule. We will have always a positive number as a result here. And fourth root of square root of x minus 2 exponent 4. Now we don't know, right? We don't know if x minus 2 is positive, x minus 2 is negative. So we're going to use the absolute value, x minus 2, because then we can make sure that this answer is going to be a positive number, a non-negative number. I mean, a non-negative number. It can be 0 or it can be a positive number. Okay? Fifth root of the parenthesis 2x minus 7, the whole thing, exponent 5. And now we apply the second rule. If n is an odd positive integer, then nth root of a exponent n equals to a. That's it, equals to a. And a is 2x minus 7. And the square root of 25x squared, well, again, this is the first rule, absolute value of 25x squared. X. 25 is 5 squared, right? So this is 5 squared. 5 squared times x squared. And then this is absolute value of 5 times x, but 5 is a positive, so we can move this 5 outside the absolute value function. 5 times absolute value of x, because x, we don't know if x is positive or negative, and this is the right answer. Objective number 6, now graph a square and cube root functions. Since every value of x that is substituted into the equation y equals nth root of x produces a unique value, the root relation actually represents a function. For each x, you're going to have only one y. The domain of the root function when the index is even is all non-negative numbers. The domain of the root function when the index is odd is the set of all real numbers. Now let's work on the first example. Check the function. if we have f of x equals square root of x plus 2 and g of x equals cube root of x minus 1. Find each function value. The first is asking here f of 7, and f is the square root of x plus 2, so we're going to just plug in 7, the square root of 7 plus 2, this is equals 7 plus 2, 9, and square root of 7 plus 2 equals 3, square root of 9, right, 3. Now letter B, f of 0, and we will work here with x equals 0 plus 2 is going to be equals to square root of 2. And the square root of 2 we can approximate, but this just represents a square root of 2. You don't need to calculate, just represent a square root of 2. And that's okay. Let us see, g of 9, plug in, and we have the equation, the function g of x equals cube root of 9 minus 1, and this is equals cube root 9 minus 1 is 8, equals to 2. That's the answer. And now g of 10, let's say this is, and use another color, this cube root of 10 minus 1, right? Plug in x equals 10, and you're gonna have cube root of 9. This is not a integer. There's no integer that will result from this cube root of 9. We can just keep it like that, or if the question asks, you can find an approximation with decimals. Now let's graph. Let's show. Let me show you how to graph square roots and cube roots. And the first example we have here is a square root, y equals square root of x. We need to find a few values. We will assume values for x and find the result for y. And I think it's better to try a few numbers that will give you integer as a result. Let me see, 1, 2, 3. Oh, okay, let's try 9. If x equals 9, the square root of 9 is 3. And another one, let's say 4. Then the square root of 4 is 2. And another number, 1. Square root of 1 is 1. And another number, 0. Square root is 0. Or we have 4 numbers. We can find more to make a graphic more precise. But right now, let's work with this 4 ordered pairs. We have 4 ordered pairs. Remember, I cannot assume negative numbers here, right? Because we're not going to have, we will not find real numbers as a solution for negative numbers. So, no negative numbers. The domain is restricted to only the non-negative numbers. That means 0 and positives. Let's find the points. So we have 0, 0. We have 1 and 1. We have 2, x equals 2. X equals 4, x equals 4, y equals 2. Right? Yeah. And x equals 9. Let me see if I can find 9. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is about here. And 3. Let's say it's somewhere here. And connect the dots, connect the points to find the graph. something like that. Again, this is not going to be used. This sign is not going to be used because we're not going to have square root of negative numbers. Only non-negative, 0 and positive. Okay? Now, another example. Let's find the graph of cube root. Y equals cube root of x. And we have the same thing. We have to assume a few numbers, a few values for x, and then find y. Let's say we have x equals 8, y is going to be 2, cube root of 8 equals 2. I will need maybe a calculator to complete, to have more values, more numbers. 1 cube root is 1, 0 cube root is 0. If we have negative 1 cube root of negative 1 is negative 1, and negative 4 we're going to find with the calculator, and negative 8, negative 2. Let me bring here the calculator. For 4, let's say the cube root equals 1.59. So 1.59 approximately. And then we're going to have here negative 1.59. Great. Let's find the points. We have several ordered pairs, and now we don't have a problem about the domain. The domain is going to be all the real numbers. We can have negative numbers as the cube root of negative numbers. This is not a problem. There's no limitation. So we start here on 0, 0, 1, 1, and we can have 4 for x equals 4. Y equals 1.59 is somewhere here, and for x equals 8, 1, 2, 3, 4, 5, 6, 7, 8, 8 is going to be kind of here, and y equals 2, right here. Great. Then we're going to have also on the other side, as with negative numbers, x as negative numbers. X equals negative 1, y equals negative 1, x equals negative 4, y equals negative 1.59 approximately. So 1, 2, 3, 4. Oops. Here. And y equals x equals negative 8, y equals negative 2. 2, 8 is going to be 1, 2, 3, 4, 5, somewhere. All right, connect the dots, connect all the points, and we have, oops. This is going to be the graph. You can represent with an arrow that will indicate that this goes on all the way to the left to infinity and the right to infinity as well. Just going back, this is the graph of the cube root. Just back a little bit to the graph of the square root. This we can write the arrow, can represent the arrow here on the right, because it goes all the way to positive infinity, but it stops here. It stops here on 0, 0, doesn't go to negative. Don't have any points on the negative domain, okay, on the negative numbers. All right, this is the conclusion of section 7.1. Let's get back to our challenge. Today we have this challenge, and I will bring here a graphing calculator to help me out, okay? And I like to use this online graphing calculator, GeoGebra, and type the equation x squared plus parentheses y minus, and we need the cube root here, cube root of x squared, and move, and this is squared as well, equals to 1. Enter, and let's find the graph, the result. If you check it out, let me know what's the first word that comes to your mind when you see the graph, the result of the graph. Here. What do you think? What's the first word? Yes, we can think about a couple of words like heart or love. I would think heart. I would think heart is the best word that applies to this graph. If you agree with me, we will write here the word heart. Thank you for watching the video, and I hope to see you soon on the next section of our course.